All right, here we are. So last video we were just talking about, we just finished up, was the dividing fractions with common denominators. And it's a simple idea as these denominators are our counters. So I have fifths, I'm making groups of 4 fifths. So I have 20 things total, I'm splitting them up into groups of 4. And I can only do that because I'm counting the same thing. We made the connection that these fifths are just counters. They could be anything. I have 20 fifths, or I have 20 dogs, I have 20 apples, I have 20 pencils. It doesn't matter as long as I'm counting the same thing. 20 apples are split up into groups of 4 apples. Okay? We need to keep that in mind, because what happens if I have something like, let's just do something very simple to start off with, is if I have 2/3, I'm going to split it up into groups of 1/4. Now, what this is saying, if I put context to it, I can say I have 2 cats. I want to split them up into groups of 1 dog. Whoa, whoa, whoa. If you have cats, how can you make groups of dogs? Impossible. Same thing here. Let's look at a different example. I have 2 pencils, and would you please make groups of 1 erasers? Sorry, sir, that's impossible. I don't have any. I can't make groups of them. Well, lucky for math, what we can do is we can actually change our numbers. And we can change our denominators numbers here by the use of what we remember as equivalent fractions. Okay? And let's have a look at how this works. So first, let's look at, well, I have 2/3. I can draw out, here is 1, 2, and here is my ghost third. 1/3, 2/3, 3/3. Okay, 2/3. With these 2/3, I'm now going to split it up into quarters. Well, this is my whole. I'm going to split this now into, well, quarters. Quarter, quarter. Okay? And we can see I still have my 1/3, 2/3. And here I've split them up into 1/4, 2/4, 3/4, 4/4. So I split them up into quarters. Well, how many quarters do I have in 2/3? Well, do I have a quarter? No, I don't. But if we look, I have 1, 2, 3. I need a third part over here to make 1/4. Well, what if I take this one? Okay, if I take this one, and what if I move it up here? If I move it up here, I now have, well, that's 1/4. You see how that worked there? I can do the same thing over here to this one. How about this one here? Can I move this one over here? What if I move this over here? I now have, well, 2 groups of 1/4. Here's 1 group, here's 2 group. Over here, do I have anything to move over? No, I don't have anything to move over. So I can confidently say that I have 2 quarters. Here's 1/4, 2/4, and I have 2 bits left over. I have 2 bits left over out of a group of, well, wait a minute, let's look here. How many bits are in a group? I have 1, 2, 3. So I have 3 out of 3. I have 1, 2, 3. 3 out of 3, I have that 2 times, so 2 groups of 3. Then over here, I have 1, 2 out of my group of 3. So I have 2 and 2/3. So I can confidently say that 2/3 split up into groups of 1/4 is the same as 2 and 2/3. Okay? Join me in the next one where I'm going to look at the algorithm and why this model matches up with my algorithm that uses common denominators and equivalent fractions. I'll catch you then.